This is a gate problem from Zener diodes, and it came in the 2002 instrumentation engineering paper. So here is the problem. A Zener diode is used as a 4-volt voltage regulator in a circuit shown. Given that the diode requires a minimum current of 4 milliampere for voltage regulation, the maximum current in milliampere permitted to flow through the load RL is dash. And this is the corresponding circuit. So based on the information provided, we know that the Zener breakdown voltage is equal to 4 volts, and as soon as this Zener diode turns on, it conducts a current of 4 milliampere through it. So the first thing that we can do is we can turn this 1200 ohms into a 1.2 kilo ohm resistance, and we know that as soon as the Zener diode turns on, it has a voltage of 4 volts across it, and therefore the current between this node and this node, or in other words, the current flow through this resistor is constant, because the Zener diode will hold on to its Zener breakdown voltage of 4 volts. Therefore, the current I can be formulated as 16 minus of 4 divided by 1.2 kilo ohms, and therefore this is equal to 10 milliamperes. So the current that is thrown from the 16 volt source is 10 milliampere. Now this is a constant value because the 16 volt source is fixed, as well as this 4 volt drop across the Zener diode, this is also fixed, and therefore we have a constant flow of 10 milliampere up to this node, following which it gets branched into this part and the one through the resistance RL. And so from here, since we are interested only in the maximum current flow through the load, note that this current will be maximum only if the current through the Zener diode is minimum. And the minimum current through the Zener diode, if we represent it as IZ min, this is simply equal to the incoming current, which is 10 milliampere, minus of the current that flows through this load resistance. And therefore, the maximum load current is equal to the incoming current I minus of the minimum current flow through the Zener diode, which is mentioned as 4 milliampere. So this is 4 milliampere, which is the minimum current flow through the Zener diode. And therefore, the maximum current that can flow through the load resistance under any condition is equal to 6 milliampere. And if we go one step forward, the Zener diode has a power dissipation of 16 milliwatt because it has a voltage drop of 4 volt, and the minimum current is equal to 4 milliampere. So the minimum power dissipation is 16 milliampere. There could be variations to this question where you can have a load resistance which is variable in nature, and then the question pattern will be that can you find out the range of variation of this load resistance for which the Zener still works in the reverse conduction mode, or for which you get voltage regulation. So in our next videos, we will look at those sort of questions.